If you've been watching the Linux world closely, you already know something big is happening. The pace of change is accelerating, the stakes are higher, and the traditional tech giants are feeling pressure in ways we haven't seen before. Today we're diving deep into Linux 7.0, Intel's rough road, Google Chrome's surprising reversal, the rise of Rust inside the Linux kernel, and why all of this together signals a major shift in the future of computing. This isn't just another incremental update cycle. This feels like a turning point. Let's start with Linux 7.0. While version numbers in the Linux kernel don't always signal radical change, the symbolic jump to 7.0 represents a psychological milestone as much as a technical one. Since the early days, under Linus Torvalds, the Linux kernel has evolved from a hobbyist Unix-like system into the backbone of the modern digital world. It powers the majority of servers, dominates cloud infrastructure, runs on billions of Android devices, sits at the heart of supercomputers, and increasingly defines the desktop conversation. When we talk about Linux 7.0, we're not just talking about a version. We're talking about maturity meeting momentum. Kernel developers have doubled down on optimizing for modern CPU architectures, better scheduler intelligence for hybrid cores, and tighter integration with emerging technologies. Power efficiency improvements are no longer optional, they're critical in a world dominated by laptops, ARM devices, and edge computing. Linux 7.0 reflects that shift. Smarter task scheduling means better battery life and improved responsiveness, especially on systems with mixed performance and efficiency cores. Security has also taken center stage. Over the last few years, hardware-level vulnerabilities and firmware exploits have reshaped how we think about operating systems. Linux developers have responded by hardening memory management, improving sandboxing capabilities, and tightening kernel attack surfaces. Features like improved eBPF validation and expanded support for confidential computing are signs that Linux is adapting to a world where threats are sophisticated and constant. But here's where things get interesting. As Linux grows stronger, not every traditional hardware giant is thriving. Intel, once synonymous with computing dominance, is navigating turbulent waters. The company that defined the x86 era now faces pressure from multiple directions. On one side, AMD continues to deliver competitive performance and efficiency gains. On the other, ARM-based architectures are reshaping expectations, especially in mobile and laptop markets. The shift toward ARM is no longer hypothetical. Companies are embracing it for efficiency and scalability. Cloud providers are investing heavily in custom ARM silicon. Apple proved with its transition that ARM-based systems can outperform traditional desktop chips in many real-world work. Meanwhile, Intel has struggled with manufacturing delays, fierce competition, and the perception that it's playing catch-up rather than setting the pace. Linux 7.0 plays directly into this hardware shift. Kernel support for ARM RACV and heterogeneous architectures has matured significantly. Linux doesn't tie itself emotionally to one chip manufacturer. It adapts. That flexibility is part of why it thrives. As Intel tries to stabilize its roadmap and regain performance leadership, Linux continues optimizing for whatever hardware pushes the envelope. And then there's Chrome. For years, Google Chrome has dominated the browser market, but recent decisions sparked debate among users. Performance concerns, privacy, controversies, and resource consumption criticisms led many to explore alternatives like Firefox or Chromium-based forks. In response, Google made adjustments that some are calling a reversal. The company began emphasizing performance improvements, memory efficiency, and clearer communication around privacy settings. The relationship between Chrome and Linux is particularly fascinating. Linux users have always valued open standards and transparency. Chromium, the open source base of Chrome, thrives in Linux environments, powering everything from desktops to lightweight systems. But the tension between open source ideals and corporate control remains a recurring theme. When Chrome adjusts its policies or backtracks on controversial features, it highlights the delicate balance between corporate strategy and user trust. Meanwhile, inside the Linux kernel itself, something transformative is happening. Rust. For decades, the kernel was almost entirely written in C. That language offers performance and low-level control, but comes with memory safety challenges. Buffer overflows, dangling pointers, and other vulnerabilities often stem from the inherent risks of manual memory management in C. Rust enters the scene with a bold promise: memory safety without sacrificing performance. It enforces strict compile time checks that prevent many common classes of bugs. The introduction of Rust into the Linux kernel is not about replacing C overnight. It's about gradually integrating safer components, especially for drivers and new This is a strategic shift toward long-term security. There was skepticism, of course. Integrating a new language into a decades-old code base is not trivial. Tool chains need updating. Developers need training. Compatibility must be preserved. But the Linux community, known for pragmatic decision-making, recognized the potential benefits. Rust in Linux represents evolution, not rebellion. It's a forward-looking move, designed to reduce vulnerabilities in a world where security breaches can cost billions. Think about how these threads connect. Linux 7.0 strengthens the kernel's adaptability. Intel faces market pressures while ARM and alternative architectures gain ground. Chrome recalibrates its approach under scrutiny. Rust enhances kernel safety from within. These aren't isolated events. They're signals of a computing landscape in transition. The broader desktop conversation is also shifting. For years, many users felt locked into proprietary ecosystems, but dissatisfaction with operating system updates, telemetry policies, and hardware requirements has pushed some users to explore Linux distributions more seriously. Modern desktop environments have become more polished, user-friendly, and visually appealing. Gaming on Linux has improved dramatically thanks to Proton and Vulkan advancements. The barrier to entry continues to shrink. When hardware companies struggle, operating systems that remain flexible have an advantage. Intel's challenges don't mean its disappearance. It still produces powerful processors and invests heavily in research, but it does mean the monopoly mindset is fading. Competition fosters innovation. Linux thrives in competitive environments because it's built on collaboration rather than exclusivity. Cloud computing amplifies these trends. The majority of cloud infrastructure runs on Linux. Enterprises trust it for stability and scalability. As data centers shift toward energy-efficient architectures, Linux's ability to optimize across platforms becomes invaluable. Rust's presence in kernel development further reassures enterprises concerned about long-term security maintenance. Let's zoom in on performance. Linux 7.0 includes scheduler refinements that better handle multi-core workloads. Improved I/O throughput reduces latency in storage-intensive applications. Networking stack optimizations enhance data center reliability. These aren't flashy consumer-facing features, but they matter deeply for servers and high-performance systems. The invisible improvements keep the digital world running smoothly. Now consider how Chrome's changes fit into this ecosystem. Browsers are effectively operating systems within operating systems. They manage processes, memory, security, sandboxes, and network connections. When Chrome improves efficiency on Linux, it indirectly validates Linux as a serious desktop platform. Conversely, when Chrome stumbles, Linux users often pivot quickly because open alternatives are readily available. Rust's integration might be one of the most historically significant developments in recent kernel history. The idea that the Linux kernel can evolve linguistically without fracturing its identity shows maturity. It proves that open-source communities can adapt without losing cohesion. That flexibility stands in contrast to corporations that struggle to pivot due to internal bureaucracy. Intel's situation underscores another reality. Hardware innovation cycles are unforgiving. Delays in manufacturing nodes can ripple across entire product lines. Meanwhile, competitors experiment with chiplet designs, custom accelerators, and AI-focused silicon. Linux's modular architecture allows it to support these experiments quickly. That responsiveness strengthens its position as the default OS for innovation. Artificial intelligence workloads further complicate the landscape. GPUs, specialized accelerators, and heterogeneous computing architectures are becoming standard. Linux remains the preferred environment for AI research and deployment. Improvements in kernel-level resource allocation directly impact training, efficiency, and inference speed. Intel's push into AI accelerators competes with NVIDIA and AMD. But Linux is the common denominator across these ecosystems. As we look forward, Linux 7.0 symbolizes resilience. It's not about flashy marketing campaigns. It's about steady progress, open collaboration, relentless optimization. Intel's struggles remind us that dominance can erode. Chrome's reversals highlight the importance of listening to users. Rust's inclusion demonstrates that even foundational software can evolve safely. The computing world is no longer defined by a single company's roadmap. It's shaped by ecosystems. Linux sits at the center of many of those ecosystems, from embedded devices to supercomputers, from cloud clusters to personal laptops. It connects layers of technology that might otherwise fragment, and here's the bigger philosophical shift. Users are more informed than ever. They question telemetry, they compare benchmarks, they care about open standards. When a company stumbles, alternatives are just a download away. Linux's growth on the desktop might still be modest compared to proprietary systems, but momentum is building. Intel's response to competition will determine its next decade. Aggressive foundry investments, architectural redesigns, and partnerships could reignite growth. But Linux won't wait for one vendor's comeback. It will continue expanding support for ARM servers, risk-free experimentation, and hybrid computing models. Chrome's course corrections show that user pressure matters. The open web remains a battleground between convenience and control. Linux users, often vocal and technically savvy, influence these conversations disproportionately relative to their market share. Rust in the kernel might inspire other long-standing projects to reconsider their language strategies. Memory safety is not a trend, it's a necessity. As cyber threats grow more complex, foundational software must evolve proactively. In the end, Linux 7.0, Intel's challenges, Chrome's adjustments, and Rust's rise are interconnected chapters in a broader story, a story about decentralization, resilience, and adaptability. A story about open-source communities, proving that collaboration can outpace monopoly. A story about hardware giants, learning that innovation cycles never slow down. The future of computing looks less centralized, more competitive, and increasingly open. Linux stands ready for that future, whether on bleeding-edge ARM servers, traditional x86 desktops, AI clusters, or experimental RISC-V boards. It continues doing what it has always done best: adapting, and that's why this moment feels significant. Not because of a single feature or benchmark, but because of the convergence of trends. Linux evolves, hardware shifts, browsers recalibrate, programming languages modernize. Together, they signal an industry redefining itself in real time.